everyone, once again welcome back to the DSA with DAX series. Myself Dax Patel, and this is our DSA series day 38. Okay, so this is series where you can find the DSA from absolute beginner to the advanced level. Okay, so now we'll move to the list topics. Okay, yesterday we saw question number 1662. It's basically check if two strings array, okay, string arrays is equivalent or not. Where we are doing this question by two approaches. First approach is from each and everything scrap, okay, and second approach is based on the our inbuilt functions, and after that we'll complete it in one line solution. If you not watch yesterday's video, you can check out that video, link in I button. Okay, so and one more task I given you to do that question by third approach. Okay, if you does not do by third approach, you can check out that approach in our GitHub repo. Okay, so now we move to the today's question. So today's question is based on list. Okay, so yesterday I told you that each and everything I'll be explaining in this video. Okay, so the list is basically in a form of the nodes. Okay, list stores data in form of nodes. Okay, nodes contains value of their current value of that index. Okay, and the next node's value. Okay, so in simply terms I can say that uh, it's basically linear data structures which stores in multiple places. Okay, in storage as in like half part is in other part of your memory and half part in like remaining uh, other part. Okay, so the first node, okay, the first node, starting node contains two parts. First is value, and other half part contains a pointer to the next node. Okay, it means like array is stored in one places. Okay, whole array stores in a one places. We memory creation time at the time array is created one memory at the time. Okay, so the problem is once you declare array, it has specific memory limitations. If the array is contains only 50 indexes, so the 51st index couldn't be stored in that array. Okay, but in case of list, it won't have memory fixed sizes. It will store each and every node to the new places. It will has your whole memory access. Okay, because the previous node contains your next node's pointer, because the last node knows where you stored your next values. Okay, so the our list has totally four types. Okay, singly linked list. Okay, which contains only single way. Okay, one way list. Like I told you. After that, doubly linked list. Okay, it's circular linked list. Okay, the last node contains first node value. So if you start a loop from that, it will contains rounding and rounding again and again repeating. After that, the circular linked list. Okay, so okay, that it's my mistake. So doubly linked list means it will contains that the previous node values also. Okay, and the circular linked list is circular. Okay, so singly linked list you go move in a one way. Okay, afterward circular linked list contains previous node value, current node, previous node pointer, current node's value, and the next node's pointer. Okay, so you can move through two way. You can move ahead or you go backward. Okay, in circular linked list. Okay, the last type of list is W circular linked list. Okay, so it contains whole circular linked list with the store of previous nodes pointer plus current node value and the next node pointer also. So in this linked list, you can move to the uh, both direction. Okay, you can go ahead, you can go backward. Also, you once you start, it will running and running inside the loop because it's circular linked list. Okay, I hope we got clear about what is link. So it's a data structure which stores data in forms of nodes. Okay, and node contains data or like a value of that, and the next node's pointer. Okay, pointer means address of next node. Next node stored in which part of your memory. Okay, so this is the list. Okay, so now we'll move to the our core part of the question. Okay, so now I'll explain the question. So first the question is merge two sorted list. Okay, you're given two sorted list. You are given a heads of two sorted linked list. Okay, the heads of the linked list is given. Okay, list 1 and list 2. Merge the two lists into one sorted list. You have to merge both lists in a sorted way. Okay, that the is in ascending order. The list should be made by splicing together the nodes of the first two lists. You have to splicing it's like a adding values to the list. Okay, return the head of the merged linked list. You have to return the head of the both merged links. Okay, so here they given you a visual representation. The 1 2 4 1 3 4. Okay, list 1 and list 2. So here they taken list 2 as a base and take 1, insert it, after 2 insert it also, then 3 remain same, again 4 taken and 4 inserted. So they got their new list. Okay, new list it's means merged list. So okay, wait here I'll set one. Okay, this is the example one. Okay, list 1 is 1 2 4, list 2 is 1 3 4, and the answer becomes 1 1 2 3 4 4. The input list is empty, another is empty, you have to return an empty list. If the one list is empty, another is 0, you have to return 0. The conditions, we move to the condition part. The number of nodes in both lists. Okay, the nodes contained in both lists is between 0 to 50. Okay, the minimum list contains 0 node and the maximum nodes contained by list is 50. Okay, the value of particular nodes which is stored in that node is between range of -100 to +100. So it's not very large. You can handle it. Okay, so the both list 1 and list 2 are sorted in non-descending order. The both lists are sorted in a non-descending order. So you just have to be careful while you are inserting values, and you have to just be carefully insert the values in our list. Okay. So for inserting in a value, we have to know such a certain things. Okay, about the list. Okay. If your list name is like XYZ, your list is you can say that if any list is there, name of ABC, if you want to the value of that okay list, so you use abc dot val. Okay, it becomes giving you the value of that list. Okay, if the value is defined. Okay, for iterating to the next node. Okay, the if you use abc dot value, it will only give the first node value, the head node value. Okay, for the iterating next and finding the next node value, you have to use abc dot next. It will like push ahead to the next node, and afterward you can use abc dot value, so it will give you next node's value. Okay, so like that you have to push list to the next to find your next values. Okay, so this is the questions. Okay, I hope you got clear about the questions and about list and its types and how it's gonna work. Okay, so now we'll move to the approaches parts. Okay, I'll explain the all possible approaches and then we move to the code part. Okay, guys. So now we move to the approaches part for this question. Okay. So first approach is like this thing is I know for you is totally new, but the approach is for this possible thing is first approach we create a new list. Okay, dummy list, and afterward that dummy list we push compare and push each and every value to the dummy list, and in the or dummy list we'll move with the at the end if one list is ended, another remain list will directly add to the our dummy list, and at the end we return that dummy list. Okay, so this is the for first approach for our okay, and second approach we don't wanna go for that. Okay, if there is remain time we move we also write second approach code, but if there is no time we'll later on another question we'll more discuss about that part. Okay, so I'll start with the first approach part. Okay, the first approach is very simple. We are gonna create one new list. Okay, so let dummy equal to new list. Okay, we have to start with node. Okay, we can directly don't create new list, we'll first create node for that. Okay, and afterward -1. Okay, so let, now we have to take one variable current which is stored dummies value. Okay, then we use one while loop until unless list 1 is not equal to null, because here you couldn't get 0, you have to use null. Okay, like this is ended, list 2 is not equal to null. Until these two lists are not equal to empty, we are continuing this while loop. Okay, inside there first if condition is list 1 dot value, okay, is less than list 2 dot value. Okay, where list 1's value is less than list 2 value, we use current dot next. Okay, current variable contains dummy. Okay, we'll move it to the next. Okay, and store the list 1 here, and list 1 becomes list 1 dot next. Okay, so what are we are doing here in the current? Okay, we'll moving it to the next index. Okay, and next node, and in the next node we're storing current list, and the list will push to the next node. Okay, so our first node part completed, and we successfully crossed it. Now we use else current. Okay, dot next equal to list 2. Okay, list 2 equal to list 2 dot next. Okay, so same as above, we're moving current to the next and storing it with list 2 value, and pushing list to the one more step away. And at the end we also have to use current to move equal to next, current dot next. Okay, now our current dot next value will store in it in our current. Okay, because we have to each and every afterward we have to use that current variable, like it will create next node. Okay, you created next node of current, but you have to link that node to our current node, so that's why you have to use current equal to current dot next. Okay, so the node is swapped. Okay, so now we'll move to the next part. So it's basically writing that. Okay, how you gonna return it. So I'll start with that. Okay, so now I'll write with the next part of this. So first we have to one condition, we use current dot next. Okay, current dot next equal to list 1 is not equal to null. Okay, in case of any of this is not equal to null, list 1 or list 2. Okay, okay, so here we moving with the our while loop will break if any of the list should be become null. Okay, so at that time here we find that which list is null and remaining list is already sorted, so we'll directly add that list to the end of the our current. Okay, so now we'll use to return dummy dot next, because we initiated with dummy value. Okay, first node, so we have to skip that and we have to start, so we'll skip that first index, first node, and then after our this gonna work. Okay, so you can see that our answer is accepted for all three tests are passed. Okay, so it will under process, it will submitting. So here the main thing we'll come doing is it's basically we'll iterating to the next of the next. Okay, in our dummy node. Okay, dummy list nodes, and inside that part we'll moving with the storing that if is less than we'll store, if it's not less than we'll skip that part. Okay, so you can see that our this is accepted, our 20820 test is passed. Okay, so I hope you got clear about today's question and this approach. It's basically simpler to understand. Uh, First, you have one list. Okay, list is basically created on nodes. Node has two parts. One is value. Another part is next node pointer, like its address. Where is another node stored? Okay, so you started with head. Head node here tells you this is the first node where you got first node's value. Afterward, second node's in address. You would use that address to move to the second node, and second node you got value of second node, and the third node's address. Okay, the difference between array and list is, okay, array is stored at one place, okay, while list is stored in multiple places at your memory. Okay, in array you have fixed size. Okay, if you declare a time you given it 50, so it will store only 50 indexes. It does not store 51 indexes, while in list you can store multiple indexes. Okay, up until you want to create one node, you create. In previous node you just add address to your previous node. Okay, so from list you have some apparent to use that things. Okay, so now we'll move to the time and space complexity for this code. And if you find any doubts about today's video, you can ask me here, okay, in comment section. Like any doubts about list or type of list or this question approach or code. Okay, so now we move to the time and space complexity. Okay, so for this approach, uh, space complexity will describe about space complexity first. Space complexity is order of one. Okay, because we'll use the like maximum one our given node, and afterwards we'll adding old nodes to that node. Okay, it does not creating entirely new list with the scratch and copying that value and storing in new list. No, it does not creating entire new list. We used one dummy node and connecting that node to here, and afterwards we'll moving with that part. Okay, so that's why space complexity is order of one, and time complexity is like order of n plus m, because we are moving with the both list ends. Okay, we assume has first list has n numbers of nodes and second list has m number of nodes. So time complexity becomes order of n plus m. Okay, so I hope you got clear about time complexity and space complexity. Okay, you can try it by another approach. Okay, if you know, it's fine. You will just understand what is list and how it's we gonna work upon that, and you can try to find inbuilt functions for this, and you can try how you can apply it. Okay, so now we'll move to the tomorrow's question part. Okay, so now we move to the tomorrow's question part. Okay, I'll open and show you tomorrow which question you're gonna solve. It's basically 696 questions. Okay, 696 questions. It's count binary substrings. Okay, it's easy level question. You can solve it. Okay, just given a binary string s, you have given a string s. Return the number of non-empty strings that have the same number of O's. Okay, zeros and ones, and all the zeros and ones in this substring are grouped consequently. Okay, substring that occurs multiple times are counted the number of times they occur. So what this trying to saying is, they given to you binary substring, like we'll see example one so you got clear about more. So here they given you example one. So input s equal to 00110011. Okay. So the output is total number of six strings are possible. Okay. So how six is consequences of ones and consequences of zero. Okay. So first is like 0011, 011100, and 0011 and 01. Okay. So how they'll repeating it like partition here. You can see that first 0011. Okay, first part, then 01, second part, like that again 1100. Okay, 100011, like that. Your two part there. Okay. Uh, Afterward, like this here in expression, they say you notice that some of these substring repeat and are counted the number of times are they occur. Okay. Also, is not a valid substring because all the zeros and ones are not grouped together. Okay, so it's not valid, but they are not grouped together. Here one more string they given you 10101. So 10011001, total four possibilities are there. So output should be 4. Okay, here they give you. Now we'll see about condition. The length of the our string is between 1 to 10 to the power 5. S of I is either 0 or 1. The string's value contain only 0 or 1. None of that out of. Okay. You have to try this question. After completing, you can post it on LinkedIn and Twitter. Mention me, okay? And if you have doubt about this question, okay, watch tomorrow's video where I'll explain each and everything about this question, okay? And if you want to code, you can check out GitHub repo. And if you're not started yet DSA the series, go to day one. Link in a button where I'll explain each and everything about series, and you can start your playlist DSA with the so to master DSM, okay. And one thing you have to stay consistent to master DSA, okay. So thanks for watching the video. Meet on tomorrow's video.